Let's talk for a few minutes about potential energy. To begin with, we'll look at some definitions, some types of potential energy, and then some examples. Let's start off with our definitions. What is energy? Energy is anything that has the ability to do work. Now, you might be asking yourself, well then what's work? Work is where forces cause displacement. Now, let me give you an example. If I have a hammer and the hammer hits the nail and the nail doesn't move any place, there is no work being done because that force did not actually cause a displacement. Whereas on the other hand, if the hammer hitting the nail forces it into the wood, that hammer has done work on that nail. That hammer has had energy, and that energy has done work. Now, when that hammer is lifted up, it has potential energy. Potential energy is stored energy. And there are several ways that you can store energy. Another definition, if you will, for potential energy is it's the energy of location. Let me give you an example. Gravitational potential energy is energy due to the distance between an object and a source of mass. Our hammer had gravitational potential energy when it was held up over the nail. Elastic potential energy is another energy of location, but it is due to the compression or tension of elastic material. Another form of potential energy is chemical energy. This is energy that is stored in chemicals and can be released by metabolic processes like after we eat something or by burning. Today we are really only dealing with gravitational and elastic. These are our mechanical forms of potential energy. So, the types of potential energy we're looking at today are gravitational and elastic. Now, one way I've looked at this is that our gravitational potential energy has everything to do with height. So if you had a choice between having your head have a bowling ball dropped on it from very, very close, or having your head having a bowling ball dropped on it from high up, you would undoubtedly choose the very close one because the higher up one has more potential energy. It has the greater ability to do work on your head. Elastic potential energy is once again due to position, but it can be found in things like springs or in objects like a diving board or anything that experiences tension or compression. Another example might be a bowstring with an arrow into it. When the bowstring is pulled back, it has elastic potential energy. That energy is now stored in this bow, ready to be released to launch the arrow forward. Let's take a look at some examples of gravitational potential energy. I have an object that I am holding. Let's go ahead and make it 30 meters above the ground. My object itself has a mass of 10 kilograms. Can we figure out what its gravitational potential energy is? Well, first of all, what do we know? We know the mass is 30 kilograms. We know the height is equal to 30 meters. We know that gravity is equal to 9.8 meters per second squared. So do we have enough information? We sure do. 10 times by 9.8 times by 30 will give us our potential energy. Our potential energy will be equal to 2,940 joules. Now, when we're looking at elastic potential energy, we recognize that objects that have been put under compression or tension can actually have a force. Now, that force that they have stored up depends upon the spring constant, or how quickly or how efficiently an object springs back, and how far it has been stretched. So let's say that we have a spring and we place a mass on it. When we place a 1 kilogram mass on a particular spring, it stretches down 30 or 0.3 meters. Now, we know, can we figure out the force that is acting on this? Certainly. 10, to figure out the force, we will use the mass times the acceleration being gravity. Then, if we divide that by the stretch, we can figure out the spring constant. So let's go ahead and do that. Looking at this, we find that we have a spring constant of 326.67. Now, this spring constant would be true for any type of mass that we put onto it. Once we know what this spring constant is, we can figure out either how much force is required to get a certain stretch, or how much stretch indicates how much force is actually being held in store. Alright, key things to remember. Potential energy is energy that is stored. There are two primary kinds of potential energy in the mechanical world that we are looking at. We have gravitational and we have elastic. Gravitational potential energy is found by knowing what the mass is, what the acceleration of gravity is, and the height that the object is being held at. Elastic potential energy is found using Hooke's law, where we know that the force is equal to our spring constant multiplied by our stretch. Potential energy is only stored energy. It's not actively doing anything yet. I hope this helps.